So we will start with a very basic geometry, that is square pyramid. So as you can see, square pyramid is nothing but a base is square. Okay, this is a base is square and which is connected to the apex with the help of four slant edges. So if you see from top, what you will get a square. Okay, you will get a square, and the front view that depend upon the orientation. So now in this problem, okay, what is given, the base side is of 40 mm and axis is of 60 mm. So what is axis? It is a imaginary line which connects the apex and the center of a base. This is what axis. So in this problem, as you can see, uh, the base side is of 40 mm and axis is of 60 mm, and the base is inclined to HP by 50 degree, and by doing this it is resting on one of its base side on HP. Okay, and we have to draw projection. So here what is given, the base is inclined to HP by 50 degree, and by doing so it is resting on its base side. This is very important. Okay, so now how to start the problem. So for starting a problem, we will consider two assumptions. The first assumption is, even though it is given that the square pyramid is resting on one of its base side, we will consider, in first step we will consider the square pyramid is rest on whole base, on its whole base. And second one, while resting on its base, you will consider it's one of the base side is perpendicular to VP. So if you do this, what will happen? From top view, you will get true shape of base. Why? Because whole base is resting on HP. Okay, and that will be square. So let's see that. So first we will get a true shape of base, that is square. Okay, and we have what? We have assumed one of the base side is perpendicular to VP. So we have considered this base side suppose perpendicular to VP. Okay, now these four slant edges, okay, they are inclined to HP, and therefore their length will get reduced, and these four slant edges will meet at a point O. Okay, apex. So this is what ABCD. This will be a top. Now what will be front view? Now front view will be a triangle. Okay, front view will be a triangle. We are looking from this side. So front view will be a what? Triangle. And height of the axis is given. So therefore, first locate the axis. Is axis height is 60 mm. And then join it by two slant edges. Okay, so this will be a front. So here what we have assumed in first step, it is resting on its base, not on base side, and one of the side is perpendicular to VP, and therefore we have got true shape of the base. Okay, now we will start with the problem. Now in problem, what is given? The base is inclined by 50 degree to VP. This base ABCD, okay, it is inclined. It is what, just like this one, it is inclined to 2VP by 50 degree, to HP, sorry, by 50 degree. So we have to draw this. Okay, so therefore now what we will do, we will just copy this geometry. We will copy this geometry and we will put at a 50 angle. Okay, now let's see, just like this one. So the base, it is inclined by 50 degree, and now it is resting on one of its side. Okay, now which side we can consider? On which side is it resting? Generally, we are considering a side which is perpendicular to VP. Now here AB, okay, AB as well as CD, both sides are perpendicular to XY line, that is VP. Therefore, we can consider any side. So here what we have considered, the CD side, it is resting on CD, okay, by base inclination, by giving the base inclination of 50 degree. Now, this front view, there is no difference between these two front view. Both front view are same. Just it is in this case, second case, the base is inclined by 50 degree. Okay. Now, in the first case, it is resting on base. Therefore, top view this one. Now, in second case, it is resting on one of its base sides. So top view will change. So how to judge the top view? Okay. So for judging the top view, first we have to locate the position of observer. So this is the position of observer. So after locating the position of observer, okay, from each point, okay, from each point, this point and this point, sight rays or projector will pass to what? Top view. Okay, so these are the projections from front. Then when it is resting on base and when it is resting on what? One of its side. Before inclination, after inclination, the width of the solid remains same, and therefore we will transfer width from first top view. It will remain same. Okay. Now where A1 and A1 dash and A meet, where B1 dash and B1 meet, where D1 dash E1 meet, that will be A1, B1, D1, C1, T1 and O1. Okay. Now after this, if you see, we have to decide which part of this square pyramid is a dark, or dark means visible. Which part of this square pyramid is visible and which part of this square pyramid is not visible. So whatever is visible, that will be dark. Whatever will not visible, it will be what? Dotted. Okay. And this will be position of what? Observer. Now first what we have to do is locate the nearest and the farthest point from the observer. Okay, I told you this is the observer. So locate the nearest and the what? Nearest and the farthest point. So which is the nearest point? So this is the O1 is the nearest point, and C1 D1 is the farthest point from the observer. Okay. So after locating the nearest and farthest point, okay, whatever geometry you have, whatever point you have located in top view, connect that all points by outer boundary. Now these are the 5 points, so connect these 5 points by outer boundary. Okay, so we have connected these all points by outer boundary. So outer boundary cannot be dotted, it should be always dark. Then coming back to the nearest point, which is the nearest point? Point O. Okay, the line which are starting from O, all lines should be visible, that is dark. So how many lines are starting from O? OA, OB, OC, OD. Now OC, OD are already dark because part of outer boundary. OA and OB left. So this should be dark. Now go to the farthest point. Whichever line is starting from the farthest point, that is C and D, should be not visible, provided that they are not part of outer boundary. Now, how many lines starting from C and D? You can see O, C and OD. Now, OC and OD are outer boundary, cannot be dotted. Then AC and BD. This is what, no, not AC. Now CD, BC and AD. Okay, BC and AD. You can see here BC and AD. Again, these are the outer boundary cannot be dark, cannot be dotted. Sorry. So whatever, which line is leaked? CD. Now CD is what? Inner boundary. It is not outer boundary, so it should be dotted. Okay, so this is what top. So what is the rule? First locate observer. Okay, whatever line starting from observer should be dark. Outer boundary should be dark. Locate the farthest point. Whatever lines passing from farthest point should be dotted, provided that they are not part of outer. Thank you.